and a very warm welcome to all of you who are joining us here. Please note that this event is being recorded for archival purposes. We are now going to commence our webinar on machine learning, disrupting industries with data, which is being organized by the Department of Computer Science and under the patronage of IQAC, M.U.C Women's College. I would like to welcome our respected principal and chief patron for this event, Dr. Sukriti Ghosal. I would also like to welcome Dr. Shishir Kumar Gorai, coordinator of the IQAC, and my fellow colleagues from the Department of Computer Science, Mr. Joydeep Dey, Mr. Anirban Bhomik, and Ms. Sonia Banerjee. I would also like to welcome all our guests, speakers, participants, students, and faculty members. The agenda for today's webinar is machine learning. Modern businesses are geared towards providing the best value to their customers. And machine learning has totally disrupted the way businesses used to be run and has changed the status quo so much so that ML has become ubiquitous in every industry today. Whether we realize it or not, whatever decisions we make as consumers are often influenced by algorithms and statistical models far away from our eyes. And what drives all these is data. Data we generate every day through our interactions, whether on social media or through purchase decisions made as consumers. So hold tight as we explore this fascinating world of data science, and to tell you all about it, we have four distinguished experts from academia to industry. Firstly, I would like to welcome our keynote speaker, Professor Sripati Mukhopadhyay, Senior Professor from the Department of Computer Science and Engineering, Academy of Technology, who is a former professor of the University of Burdwan. He will be speaking about machine learning for data analysis. We are delighted to have with us today Mr. Deepankar Arora, who is the lead data science consultant at FICO. He will be presenting the data science journey, how raw data are transformed into actionable insights. We are pleased to have with us Mr. Satrajit, Head of Advanced Analytics at Tata IQ, a division of Tata Industries. And he will be talking about forecasting, specifically time series forecasting and how machine learning can be leveraged to do that. Finally, we have with us Mr. Yazdan, who is a data scientist at Aditya Birla Group, who will be presenting some interesting applications of machine learning and how it's used in the industry. Thank you all for taking time off your busy schedules. We are delighted to have you all here. Without further ado, I would now like to request our respected principal, sir, Dr. Sukriti Ghosal, to kindly say a few words and deliver the inaugural address. Sir, please.
Good morning, everybody. At the very beginning, let me extend this welcome to all the distinguished speakers today, especially Professor Sripati Mukhopadhyay, who I had a long association with Professor Mukhopadhyay, who is a senior professor of the Department of Computer Science, Burdwan University, and also acted for some time as the registrar of the University of Burdwan. And I would also like to extend my welcome to Mr. Deepankar Arora, senior data science consultant, Mr. Satrajit, Head of Advanced Analytics Industry, and Yazdan Khan, Data Science Birla Group. So I think that this is a new venture that the college has made under the guidance of under the initiative of the Department of Computer Science, college, because never before we had, as far as I can remember, we had such kind of collaboration between the academia and the industries, which is also the thrust is here, how the academia can give support to industries and industries can create posts and vacancies for the graduates who are produced by the academia. So the relation between industry and academia is a kind of symbiotic relationship, and the collaboration of academic institutions and industries is always emphasized by all the higher education regulatory bodies like UGC, and even the state government also wants that. So I would like to congratulate the Department of Computer Science, the faculty, for taking a very bold step in this regard. Now, insofar as the topic of the seminar is concerned, I have the knowledge of that. As I know that machine intelligence or artificial intelligence has been the buzzword in recent time, and how machine intelligence or artificial intelligence can, um, you know, help us, and whether it can rival human intelligence. That is a very widely discussed topic. Machine intelligence is appreciated for its accuracy and speed, but so far as I know, that it cannot be a substitute for human intelligence because it cannot innovate. It can process data at a very high speed, and therefore it is appreciated for its accuracy. It can predict on the basis of mathematical calculation, but innovation should come from human agencies. Human beings, they innovate. Machines are programmed and machines are used for the purpose of processing. This is what I know. So, the topic, one interesting aspect of the topic is that disrupting industries with data. What does disrupting mean here? I do not know. We can, or collected information can enrich industries. For example, we are giving a like on Facebook page of a car, and that is being used as data by the data scientists, and the data scientists are associated with the industries, and therefore they are designing the car in that way. But how can it disrupt industries? I do not know. Has the webinar, those who have the webinar topic in mind, are they thinking that this data, the huge chunk of data that is always pouring in, that needs some filtration, otherwise that will confuse, or some other idea they have in mind, I do not know. Anyway, though it has been described as an inaugural address, it should not be treated as an inaugural address, because inaugural addresses are usually delivered by people who have sound knowledge of the topic in question. I am a man from the humanities group. I don't have even the smattering of the topic, but let me describe it as a welcome address. I welcome all the distinguished speakers for agreeing to spend their valuable time, for taking part in participating in a discussion this morning in response to our call. I thank them all. I thank the IQAC and the faculty, all the faculty members of the computer science department for taking this initiative of arranging the webinar. I thank all the participants who have been listening to this discussion, which is also being recorded, and it will be available in the future. The participants, without audience, no speech is complete. So the objective of arranging this webinar is not it is not just adding to the college performance, but it should add to knowledge. And I think that in that respect, the webinar must be very successful. And another aspect of this webinar that I appreciate, that the host and moderator both are students. Students should give a space for moderating, for anchoring, for hosting. I would thank the faculty of the Department of Computer Science for thinking in this line. Usually we are very conservative about giving space to the students, but I congratulate the faculty of the Department of Computer Science for coming forward to give the students a space. So I again thank you all. I don't want to encroach upon the time slot of the distinguished speakers, and let me again wish the webinar all success. Thank you all. Over to the host and moderator. Thank you very much.
Thank you so much, sir. I would request all our participants to keep their cameras turned off and mics on mute during the entire session. Should you have any questions to our distinguished panel of speakers, please feel free to post them to the Google Meet chat, and we will ask those questions on your behalf during the Q&A session. Thank you. To conduct the rest of the sessions, I would now like to ask the host for today, Archita Goswami, to please take over.
Good morning, everybody. I am your host, Orchita Goswami from the Department of Computer Science. It's my pleasure to welcome you all in this webinar where we are going to learn about machine learning. I would like to extend a warm welcome to our eminent speakers. We are indeed grateful for your gracious presence. Also, I extend a warm and hearty welcome to our faculty members and also our participants who are all set to make this webinar a remarkable one. Thank you. We are delighted to have with us Professor Dr. Sripati Mukhopadhyay, Senior Professor, Department of Computer Science and Engineering, Academy of Technology, and former Professor at the University of Burdwan. He has also served the University of Burdwan in different capacities like Professor and HOD in the Department of Computer Science, as Principal in Institute of Technology, as Director of Academic Staff College, also as Registrar. He has done M.S.C, M.Tech, PhD in Computer Science and Engineering. He has over 35 years of experience in teaching and research. He has also organized a good number of national and international conferences and has successfully guided 10 research scholars for their PhD degrees. His field of interest is applied artificial intelligence and allied areas. I would like to request Dr. Sripati Mukhopadhyay to kindly deliver his keynote address. Please, sir.
Okay, good morning to all of you. First of all, I would congratulate the Department of Computer Science, M.U.C Women's College, for organizing such an advanced webinar on such advanced topics. First of all, I shall congratulate Professor Dr. Ghosal, Principal, M.U.C Women's College, for his heartily support to the Department of Computer Science. I know very well, under his able leadership, the department was started in Women's College. Now, I think this is the youngest department in Women's College, and they are conducting such a nice seminar. I know all the faculty members there, all are my students. Dr. Akash Nag actually given an opportunity to me to talk in front of my students and esteemed colleagues. So today's I'll give my presentation, and before that I should say that Professor Ghosal has very nicely told that this is a branch of artificial intelligence, right? Machine learning is a branch of artificial intelligence, and it has become so popular. All big industries and corporate houses need to analyze big data for their decision making. And here, actually, the decision will be taken what we call on data analytics, not data analysis. Data analysis is the statistical inferencing process that is a part of that bigger thing, machine learning and data analytics. Here, I have concentrated on learning from data. So this is artificial learning, automatically learning process. So let us give the presentation and discuss one after another. Actually, uh, 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 machine learning is that much. We have huge volume of data, big data source, and the computer will automatically learn from that huge volume of data. You have heard the name of big data, which is scattered over cloud. Okay, and here our purpose is to get a sample from that data. How to get that sample? That is the purpose of machine learning. Machine learning will do that. So you have a big source of data, and from that big source of data, actually getting a sample and then analyzing those data. Now, there are different machine learning paradigms. First of all, the paradigms of supervised learning and unsupervised learning, reinforcement learning, mainly three types, and there are subtypes. So when supervised learning is applicable, it is actually you have some input data and you want to produce the output. For example, suppose you have data set like this, say you have set of customers and you have the data set input as name, age and salary, and output is whether he will purchase a computer or not. Okay, so you have a set of data, say 50, 60 like that, and all data are to be treated as sample. On the basis of that sample, actually these input data sets you are calling actually training data set. Okay, and out of those training data sets, you are keeping say 15 to 20% as testing data set. And what is your output? Output is whether the customer will buy a computer or not. That is the type of output variable, either yes or no, or you can encode it as 0, 1 or plus 1 or minus 1, whatever you like. Now, we have to set some algorithm. We call it model. You have to write that algorithm or model so that it will learn that data. It will learn from data, what is known as learning from data only. Okay, and whenever you give some unknown data, it will correctly classify whether the new customer, okay, actually the customer set is very big, but you are taking only a sample of size say 100 or more. Okay, you have to take 100 minimum so that you can apply statistical Gaussian distribution. So distribution of data is most important, and you have some algorithms, you have to write them, what we call it model, and that algorithm will learn and correctly it will produce the output. So you have some data set and being trained under the supervision of a teacher. That is, you have the training data set, out of that you have test data set. So when you are getting correct result for testing the data, after that whenever you apply some unknown data, it will correctly classify. That means it has learned, the algorithm has learned. There are different algorithms, I shall name them later. Now, training as defined by in that book, that is Russell, Norwegian Russell, that is artificial intelligence, a modern approach. And the second chapter is on agent, learning and agent. He has very nicely defined agent. By agent, we see what is intelligent. Agent is a software which is intelligent. It can take independent decision. Now, you are giving input to X, okay, and it will produce some output. If that output is okay, then actually you will understand that agent is trained. Agent not necessarily be the computer. It may be human being also. But what is happening after giving training, it will learn better. Its performance will increase. Okay, its performance will increase by, so you have some performance measure also. if you consider this as P, when I shall come to consider the actual model, I will say that there may have some error. What is the amount of that error? We shall discuss with that. If that error is minimum, then only we accept that model. So machine learning is nothing but developing models or algorithms which will learn from data only. Okay, that's why I'm given the title machine learning for data analytics. Okay, and at the end level, you have to apply statistical tools and techniques because you are considering samples only and you are inferring regarding the whole population, which is very big. Okay, but one question arises: how will you get that? For that, we have the tools and techniques available. Say HDFS is there, Hadoop file system, and you can get a sample from big data source to a single machine. You can process that data. Okay, so the learning process for classification model is like this. It has many application areas just for fraud detection, opinion mining, medical diagnosis, sequence analysis, all these things. Okay. So fraud detection means what? Let us consider a transactional data. Okay. And at this point, I should mention that basically data mining actually mining hidden gold from data. You have the data only and nothing else. From there, you can just invent or discover the hidden pattern. Okay. So suppose there is a transaction is going on and there are some fraud cases. By machine learning, it can just detect the fraud transaction. Okay. And what is opinion mining? Opinion mining, also known as sentiment analysis, just for analyzing social network sites like Facebook, Twitter, like that. And medical, say, consider another example, say medical diagnosis. Here what you can see, you have data set. Data set you can create from any hospital or nursing home, or even you have, say, data sources, you have databases for data sources. For example, M.U.C machine learning laboratory in Switzerland. Here you have data of all types of patients, like diabetic patient, heart patient, all those things. You can do the patient monitoring system using IoT devices. So IoT means you have sensors, you have connected them to the system, and you can monitor patient health. So these are some of the applications. And supervised learning has different architectures. Models I have told you, for that you have different architectures, like nearest neighbors. Okay, say K nearest neighbors, that is algorithmic approach. Okay, say decision tree, say Bayesian network, this is probabilistic approach, support vector machine, artificial neural network. These are the different supervised learning architecture. Okay, but whatever, depending upon the problem domain, you have to select the supervised learning architecture. But all the time, you have to measure the the error, estimate error. Okay, you have to estimate the error. It may not give 100% accuracy, but accuracy must be more than 95%. Okay. For example, say linear regression, we know that is simple statistical model. After that, we come to logistic regression. Logistic regression is a classification model. But linear regression, basically it is a predictive model, predictive analysis. So some mathematics are there. You are considering, say, we are considering, say, linear fit. So we have some decision boundary. That boundary is just classified. And it can predict whenever some unknown data comes. And in logistic regression also, we can classify. For that, the first example what I told, that whether a person will purchase a computer and you have the input variables age and income. But these are the challenges, whether these two input variables, what we call parameters, only these two variables are sufficient or more variables are needed. For example, nowadays, online lectures are going on. So you have to include what is the need of computer. So it doesn't purely depend on age and income. Okay, so these are the issues. So a data scientist has to look into this thing. On the basis of his experience, he has to decide what are the input parameters and he has to fix the level. Here we are considering only two-class classification problem. So here, if we take logistic regression, so error rate will be minimum. If we consider, say, Bayesian network architecture, then what will happen using Bayesian architecture, it is a probabilistic model. So the answer will be, or prediction will be, what is the probability that a person whose income is this, whose salary is this, he will purchase a computer. That is, what is the probability that that customer will purchase a computer. So what is the probability means some error estimate is there. If the probability is less than 95%, so that model will be readily rejected. Okay. So what I am trying to say, that the agent's performance, here if we take computer, so computer performance will increase and we can minimize the misclassification rate when we really want to classify. So there are different models. Similarly, say artificial neural network, and you will be studying in your syllabus that artificial neural network here is being used for classification. Okay, it has immense application in different fields, but for data analytics point of view, I can say that you can classify the huge volume of customers into segments, okay, or groups. So in this way, we have different architecture. Now, the next paradigm we shall consider is unsupervised learning. This method is used for unlevel training data. You have the data set, you have the input variables, and what is the output, you do not know. You have to generate that. So here we shall consider two types of, here we will discuss only two types. One is called clustering and other is called association rule mining. What is clustering? Clustering is basically grouping of similar data. Similar data we shall group. Say similar customers in a group, or say you are trying to create some tutorial group for students. This is a simple application. I want to explain what is clustering with the help of this example. Okay, suppose there are 70 students in a class. Suppose you have 3 or 4 teachers. So you do not know which students will come into which group. Here we call cluster. Clusters are basically cohesive grouping. That is, different objects of the same class are similar in nature. But if you take 2 different objects from 2 different classes, they are dissimilar. Okay, so how to do that? Here, in this problem, we can call it cluster. So here, actually, it has also different applications. For example, say customers' data. Okay, here, how it will be used? To discover segments of customers. In business environment, we call it segment. Okay, so customers, you do not know how many segments are there initially. There may have 2, there may have 3, there may have 5. So if there are 5 types of customers, so 5 groups are there. Classification is different thing. You know in advance what are the classes. For example, what I have told earlier, that you can just classify into 2 groups for purchasing computer or not. Okay, so that output is leveled there. But here in unsupervised learning, this is unleveled data. You have the data sets only. Okay, and machine learning will learn by its algorithm how to discover those groups. So it's for image processing or computer vision or pattern recognition to recognize that the letters or words and sentences correctly, you have to cluster them. Okay, and say outlier detection or mining. Say in case of transaction processing, if you say that some object does not belong to any group, it is far away from the different groups. So that is an outlier. Say this is very important. This is a very active research area for outlier detection or fraud detection. Okay, so after clustering, means roughly you can call it after grouping, you will see some customers are not belonging to any class. Okay, in that case you can detect the fraud. Okay, so in ATM, actually, to detect the frauds, you have to use clustering. Next type of unsupervised learning is association rule mining. First of all, you should remember this is used for transactional data. What is transactional data? Transactional data means you have data sets. Okay, different, say, consider market basket problem. Suppose you have gone to some shopping mall and purchasing item. So, what is a transaction? Transaction is a group of items you are purchasing together. What is the association rule here? How to determine the association rule? Say, first of all, you have to find the frequent pattern. Okay. From there, you have to drive association rules. For example, say a customer is buying milk. Okay, he is likely to purchase butter also. Okay, so drive association rule. Suppose A is an item, B is another item. So first of all, you have to find the frequent item set. That is the transactions which contains both A is an item, and A union B is another item which contains both item A and item B. That means in that particular example, consider A is nothing but milk and A union B, milk and butter. Okay, so what is the rule? See, if A purchase milk, if a customer purchase milk, then he is also likely to purchase butter. Okay, that means A implies
Sir, are you there?
B, that is the association item, should be placed nearer. Okay. Some another important applications, find patterns is sequences. Okay, and sequences generally is, for example, time series data. This is also falls under unsupervised learning or association rule mining. And graph-based networks, graphs or subgraphs. You are finding patterns in graphs. This is immensely useful for analyzing social networks like Facebook, Twitter, or it is used for computational biology also, for analyzing computational biology. Now, why we are using machine learning? Actually, data mining and machine learning, in data mining what we have? We have huge volume of data. Okay, but machine learning, you may have huge volume of data or big data, and using some machine learning technique, you are getting the sample. Okay, so here for data analytics, from big data means huge volume. There are various characteristics of big data. Okay, and big data analysis or big data engineering is just fetching the sample. Sample should be random sample. Okay, and there are languages like Python, R, they can do those jobs. They can call the machine learning tools and techniques and fetch that. And after that we can analyze. In data mining, basically, you are discovering the hidden pattern, which will ultimately help you to draw conclusions. Okay, so drawing conclusion with the help of data mining. So data mining uses machine learning, or you can say that machine learning lies in the heart of data mining. Or one can say that clustering as a precursor to data analysis. Why we call it precursor? Because we have the universe, which is very big data, and we are getting a subset of it. It is called sample. and we are analyzing that sample with the help of statistical tools and techniques like the descriptive statistics, like statistical inferencing. Okay, statistical inferencing, whatever you say, again you have to give the error estimate. Why, how will you give the error estimate? Error estimate, that is your knowledge, whatever you are driving using machine learning tools and techniques, that should be above 95% or 99% or 100%. As for example, in case of association rule mining, whatever rule is deduced, what is the measure there? Performance measure. How the performance, whether the performance is increasing or not, how will you measure that? That will be measured by a term called confidence. How much you are confident that this item should be purchased with this item. In case of medical diagnosis, if these are the symptoms, what is the confidence that the disease is this, something like that. So it is just called predictive analysis. Predictive analysis. Okay? And another paradigm I should touch up here, that is reinforcement learning. Reinforcement learning means what? You may not have any data, or you have some data which is not enough for analysis. Okay? As for example, to learn bicycling. Okay? You don't have any data. Okay? You have to generate data. Reinforcement by punishment and reward you have to learn. All types of online learning methods are reinforcement learning. Even if you purchase a new machine and you have another machine of the same type, you want to compare the performances of these two machines, or say 4 machines, 5 machines, all those things you have, how to compare that? Because the new machine you have purchased, you don't have any data. For that, again, you have to go for statistical method called design of experimentation. You have to generate data which you will consider as sample. Okay? On the basis of that, you will generate data and you will take an appropriate model. Okay? And accordingly, you can draw knowledge from that data set. Okay? So, the time is now. Yes, so now I shall stop here. Okay? So, I have talked about different learning paradigms. What are the models? How it is being trained from data itself. That's all. If you have any question, you can ask me right now, or we have a separate session. That time I shall also come and I am ready to answer your question. Thank you all.
Thank you, sir.
Thank you, sir, for enriching us with such knowledge. Now we are pleased to have with us Mr. Deepankar Arora, Senior Data Science Consultant, Decision Management Suite, FICO. He has over 11 years of experience in analytics. He started his data science journey with Hewlett-Packard supporting HP's printing business. At FICO, he is helping clients harness the power of data into business decisions. He holds a master's degree in business analytics from University of Cincinnati, Ohio, US, and a BS degree in marine engineering from Birla Institute of Technology, Purani, Rajasthan. I would like to request Mr. Deepankar Arora to kindly deliver his presentation. Please, sir.
Thank you very much. So, good morning, everyone. Right. So, before I begin, I would like to thank the faculty of Computer Science Department and the principal of M.U.C Women's College to give me an opportunity to come to this forum and give a talk. My topic for the day is a journey from data to insights. I will give you an overview on what it takes to draw some meaningful insights from the data, and I will also touch upon what has changed in the industry, right? So what was the analytics industry 2 decades back, and how the future looks like. So without wasting any time, let me just quickly share my screen, and you guys can let me know when you can see. Give me a second. So is it visible now? I am sharing a presentation. Okay.
Yeah.
So yeah. So let me move forward. So thank you, Archita. Thank you for giving introduction about me. So I have 11 years of experience with analytical delivery, analytics consulting, operationalizing analytics, and currently I am analytics pre-sales. In terms of education, a master's degree in business analytics from University of Cincinnati, Ohio. And in terms of experience, I started my career as a marine operation engineer back in 2005, and now I am a senior data science consultant at FICO. In terms of my technical skills, I'm well versed with data mining, machine learning, soft skills. And in terms of my tools and technologies, I'm well versed with R, Python, SAS, right? So a typical tools with a data scientist would use any given day. So just a small brief intro about FICO, right? So FICO is one of the pioneers in use of predictive analytics and data science. Founded in 1956, so good 60 years into analytics, and then multiple broad range of products to help multiple industries. So in terms of highlights, what FICO has done, right? So FICO started, as I said, in 1956 with credit scoring, automation of, a typical analytics function. In 2010, we are world's fastest optimization. We have world's fastest optimization solver. We have self-calibrating analytics for fraud, economically calibrated credit scores, right? So there is a lot of analytic products which FICO offer, and I am more centered here when it comes to optimization practice at FICO. So moving forward, right? So I am just for some humor, right? So look at the picture here, right? So there's a correlation between people having sales head and my sale, right? So typical inference a business user will draw. We found this correlation in the data. Everyone take a razor and shave off your head. Well, correlation is not causation, right? So data to insights is the same. And what we aim to answer is, what does it mean? Why do we need it? How can we do it? Who are required? Where can it be used? So let's see the journey of analytics and how it has evolved over time. So in the 2000 to 2010, analytics was pretty nascent, and it was only used by banks. Banks and financial sector were the one who were using it day in day out, but not a lot of industries. Then between 2011 to 2017, things grew. A lot of big data platforms came, and analytics started growing. Maturity came now 2017 2020, with a lot of platforms coming in, from Google to Azure, Microsoft Azure to AWS, and now we are slightly heading towards future, and wherein I'll talk about one of the points that Dr. Ghosal mentioned in the beginning, right? So how we can make ML and AI more useful. So let me take back you to the history, and I'll rewind back to 2006, right, where I was working as a marine operation engineer with one of the oil tankers. So I was their offshore floating staff. So I never had an office or a white collar job. I was working on ships as an operation engineer. So the problem statement, which my chief engineer that time gave me was, Deepankar, can you forecast the demand of lubricating oil consumption for the fleet of oil tankers, right? So ship engines are huge. It's not that they will just consume lubricating oil once. You have to give them a quantity of lubricating oil every now and then, right? So they wanted to forecast the lubricating oil consumption for fleet oil tankers, because it helps in doing the budget planning, PLN and other stuff. Now, the solution that I was able to deliver was good for the ship, because I had all the records maintained in Excel, but the model failed to work for the entire fleet, right? So when the same model I tried to apply to the entire fleet, it totally failed. Now, the model failure reasons: scattered data, no central repository, right? So at that point, analytics was not that prevalent, and then most of the companies were not maintaining any central data repository, right? So obviously there was some missing data I could not process, right? So, and hence the result, right? Apart from that, forecasting with Excel sheets, right? With Excel sheets, you really cannot build a sophisticated model. So back in then, I think SAS was the major player in the market with really costly licenses, versus now where you have R, Python, open source, and they can do as much as a SAS would do, right? So that was another reason for the model failures. Now, other challenges that time I faced was, data science was considered as an isolated activity, right? So only very few practices were doing it. Businesses tend to go more with their gut feeling, instead of relying on the data. There was no formal approach, no interactions with the businesses, and it was difficult to manage and update and scale, right? So as I said, right, there was no central repository, so you cannot really update data, you really cannot scale, you cannot do anything. Now, model management was also infeasible, right? So even if you had the model, and tomorrow if you are changing to some other model, it was very difficult to manage. So that was back in 2006. Now, what has happened in 2011, right? Did things change a lot? Yes, of course they have. Now, what businesses have today is they have businesses look towards data. There are typical data and IT team. So business approaches, a formal approach to analytical projects have set in, right? So businesses do look to use the data and derive some meaningful inferences. There is a culture in organizations which have come up, and data to insights involve multiple entities interacting together. So today in an organization, you will see, marketing team is talking to the data science team, data engineer team, which was not happening in early, I would say, less than a year 2010. Now, there were also data and IT, infrastructure which developed, right? So IT platforms were set up for analytical projects, right? So you must have heard about Microsoft Azure to Amazon Cloud, to Google Colabs, right? So IT platforms are set up for analytical projects. Data from multiple sources were now available on a single platform, right? So even though different departments work in silos within an organization, you had data, you have data in a single repository. Data massaging for model development was made feasible. Roles, right? So what also happened organizationally was roles evolved, right? There were data engineers, there were data scientists, there were operational research scientists. They got well defined, right? So data engineers were typically those people or folks working in harnessing the data. Then data scientists who are working more with algorithms, connecting the dots, and then predicting the future outcome. Now, then operational research scientists who are more experienced and well versed in prescripting a solution, right? That got well defined. Tools, analytical tools and software tools and software invaded the market, right? Stages in analytical lifecycle got defined: design, exploration, modeling, visualization. So what happened at this point in time, even though the data was complex, you could visualize it and see some patterns. So that became more prominent. Programming languages and UIs became friendlier, right? So today R versus R in 2010 is very different, right? R has evolved as a functional programming. Even Python, right? Python has a lot of libraries like scikit-learn and others. Visualization, it made data analysis and storytelling more compelling, right? So what a data scientist also needs to do is, the mathematical model needs to be conveyed to the business, right? Business users won't understand your mathematics. And what happened was a lot of visualization aids came into the picture. So you had Tableau, you had Power BI to different other, even with R and Python, the visualization became compelling so that the business users can really appreciate, what data is saying. And hence, you see the businesses making more of data to make decisions. Now, let me take you through, what happens during an analytical life cycle and how do you derive from data, you reach to insights. So first step is generating the data, right? So today you have enormous resources of data. So you have structured data records, be it a relational database or be it some Excel sheets or flat files. You also have some unstructured data coming in from your social media. You have your mobile apps, you have photos, audio, video, which are unstructured data. Now, every company harnesses this data, right? So if you are a manufacturing unit, right, you might capture your sales data, which how much you're selling. You will also capture some of your feedback from your comments from your customers, right? It can be through social media, it can be through call center transactions, or it can be comments or photographs which somebody would upload. For a bank, it's a transactional data which they already have, plus they have other sources of data, how many time a customer is interacting. So all this is being captured and taken to a central place, right? So that's where comes the stored data, right? Now, one more thing that to remember now, right? When you store the data, right, you have various applications now. And again, as I said, right, the storage can be company wide. So you can have one single repository, you can have a one big data lake where all your data is residing. But this raw data is something like crude oil, right? So can you use crude oil in its raw form? The answer is no. Same way, this data needs to be harnessed, right? And this data needs to be changed into information which can be then leveraged to generate insight. And hence we move to step 3, which is extract, transform, and load, right? So herein comes data engineers, a bunch of computer science graduates with really good skills, right? And what they know is creating data pipelines, doing data integration, doing data warehouses. So that's where a data engineer comes in. Then post that, you also need to have some warehouse, right, where your data scientist and your businesses can use it, right? And there comes a part where data engineers and data scientists and BI developers all come in together, right? And the important point now is, what data to choose, right? So one important point to keep in mind is always choose the data with the end objective in mind, right? So you have multiple data repositories, you have multiple data layer aggregation, but what's important is always choose the data with the end objective in mind. For example, if you want to strategize on your pricing, right? So how should you price your new product, right? You should be looking into the data for the products, what has happened in the past, how your new product launches have gone. So you should have that data pulled in. Keep it simple and choose the most relevant indicators, right? So you might be collecting a lot of things, a lot of data, but ensure that you focus on the most relevant indicators. If you obviously take all, yes, it becomes a computational challenge. Machine learning algorithms do consume a lot of computing resources also, though they are available in abundance, but you should still keep in mind that you should choose the most relevant indicator. Also ensure that the data matches with the most recently reported trends. So you should do some kind of a data sanity checks. And then one of the most important part is involve your business users at this stage and make them a part of the data process. Why I'm saying this is because data science, though it is a science, but it's more of an art. You need people who understand the business, right? Who know how business behaves to be there when you are processing this data. For example, I am giving you an example. So your monthly average sale might be just say 250 units for a given product, but suddenly in a given month you see a spike and the sale is 800. Now, as a data engineer or data scientist, you would say, okay, this record looks to be abnormal. I will do some capping or some standardization with it. But then if a business user is involved, you can go to them and you can ask them, hey, we see this. What's the problem? And the business user will say, okay, yeah, we know that, there was some backlog and we didn't have inventory. So we shipped it and hence the data. Or we had a big deal with a bigger organization and hence this number. So keeping your businesses involved as a part of this process is always lead to a more successful data project. Now the last step in the last few steps are more towards getting the insight. So you have processed the data. Now the next step will be manipulating the data, right? So you cannot really process terabytes and gigabytes of data. So what you do now is you create dimensional tables and you create some fact tables which can be used by your analysts, developers, and data scientists. Then once that are created, you come to the data modeling, and your data scientists will come in. And what the data scientists will do is, they will visualize the data, they will find the pattern, right? And they will also do some feature generation, right? So they will see the shape and size of the data, see the data types, analyze the missing and outlier values, identify important statistical information, correlations, input, and target features. So this all takes a good amount of time. And post which, the data scientists will typically validate all these things with the business. And then what you go for is the model or algorithm selection, right? So there, as Professor Mukherjee explained in the last talk, right? So there are paradigm of algorithms available today. So you have supervised, you have unsupervised, you have reinforcement learning. So you have different methodologies, but you will choose your algorithm based on your problem, right? So if your decision is to predict sales, you will choose an algorithm like regression, versus if you want to predict whether a customer will churn out or not, you will choose a different algorithm, right? So you will do the algorithm and the model generation. A data scientist will typically do that, and then you will review your model output and incorporate any feedback from your businesses. And that's where you have a good model. Now you have reached your insights, right? So now this model is the outcome of this model is which is giving you insights into what is going to happen in the future. Moving forward, right? So in the last slide, I explained, predictive modeling, right? But is it the one which is sufficient for the businesses? The answer is no, right? So your descriptive analytics, typically there are 4 types of analytics, and a descriptive analytics is typically what's happening in my business. It's comprehensive, accurate, and live data, and uses more of visualizations. Diagnostics is why is it happening, right? So ability to drill down to the root cause, ability to isolate all confounding information. Predictive is what's likely to happen, right? So that's what I talked about, and that's what we did in the last step. But that's not enough, right? So what's going to happen in future, right? So as a bank, which is the customer who is going to churn out. Or as a e-retailer, which is the customer who is likely to make a next purchase. Or you might know that this is how your sales will look like in the next 6 months. But what do we do? Can businesses derive information out of this? No. So there comes the layer of prescriptive analytics, right? Now is we take this predictive model, we take the input from the predictive model, and we apply some business constraints. We bring in the business process and derive some decisions. For example, as I said, right? So you have projected from your predictive algorithm what is going to be a demand for next 1 year. Now, you have this much of capacity in your factories, you have this much warehouse, you have these many vehicles. You now, with the demand, and all these constraints, you will come up with a strategy. How much will you manufacture in a given day? So those all strategies are done by prescriptive analytics, and that's where the whole process from data to insights is complete. So I'll move forward to a case study that we very recently did, right? So for a telecom carrier service provider, right? The problem that this client was facing was they were seeing, so they were using an unscientific process of pricing, right? And basically, whenever their cost used to increase, they used to increase the price, otherwise used to drop it, but they were not reading the customer sentiments, right? They were not really studying how customers respond to your prices, right? So as a solution, what we did was, we first built a set of predictive models, right? So these were to predict the price elasticity of demand. When I say price elasticity of demand, what you're trying to do is you're trying to ascertain if I do a 1% change or a unit change in my price, how much does my demand get impacted, right? So typically, as you increase the price, your demand will tend to fall. As you reduce the price, your demand will tend to. So what I'm trying to ascertain is what is my coefficient, or what is the percentage change in demand by percentage change in price, and that's what is known as price elasticity of demand in economics, right? So we build a predictive model first. So we took the data, harnessed this, did all the steps as I covered in my previous slides, and then we build a predictive model, right? So there were again a lot of steps involved here, right? We did outlier treatments. We also did some training and test split, right? Just to confirm whether the model is robust. Once this predictive model is done, it's giving me a price elasticity, but can I use it directly to tell my customer that you should be pricing your calling volumes or your per minute rate by this? The answer is no. So then comes the prescriptive model, right? And where what I'm trying to do is I'm trying to maximize the profitability, right? So I want to maximize my profits subject to the demand. So my constraints are that my customer demand should be met, and also in a given region, I should be getting these many minutes overall, right? So based on this, these models are built, and what we will get is some price elasticity curves, right? So you will generate some curves which will show you your profit to price relationship, and based on that, we will do a price increase decrease action, right? Further, what we did was just to study, how our customers are behaving. We split our customers into two groups, test and the control, and to our test groups, we will give the price change. To a control groups, we won't, right? And after that, we will try and do some hypothesis testing and see, does the pricing change make an impact or not, right? So once we did all this, what we saw was there was a 13% increase in average daily gross profits. There was a 100% increase in demand in over 500 different customer locations, and we delivered the model to react to the customer behavior and prescribe an optimal price, right? So this was happening in real time. And also what we did was we set up an effective tracking mechanism to monitor the impact of pricing actions. And finally, we generated some BI reports for the business users to make informed decisions, right? So out of this, we created a platform, given it to the sales team of sales
Sorry
and
to
marketing
interrupt,
team.
Deepankar.
Yeah.
I'd request all our participants to please turn off their cameras and mics. Sir, Rishi Gopal sir, if you please. Thank you.
Okay, so Akash, can I go ahead? Yeah. So, as I said, right, so what we delivered, I think there's still some noise in the background. So I'll wait for the line to be muted.
Okay.
Please, Rishi Gopal Mondal.
Okay. Okay, you can continue.
Yes, I am here.
Sir, could you please turn off your mic so the speaker can speak? Thank you, sir.
So finally, at the end of this whole project, what the client got was a platform, right, where their sales people can log in. Everything runs in the background, recommends the price, they can see what's going on, and then they can take their informed decisions. So that brings me to the journey, right? Now, where is the future headed, right? Where we are headed. So ML AI algorithms are black boxes, right? So they take data, they give some outcome, but they are a black box, right? So there are still organizations, they don't want to rely on that, and hence, what you are seeing now in the future is to make these black boxes or these algorithms more explainable and more ethical. Organizations are moving towards explainable AI or ethical AI, right? So that you are very much sure that these algorithms are not discriminating towards a certain demography of people, right? So there can be a case where your random forest model or sophisticated neural net model is you have built is trying to make a decision which is not taking into account the entire society, and it can be because of the data nuances, right? Now it's hard to rely such a model. So even if you see a practices like a risk in bank, they still don't prefer ML and AI algorithms. And the reason, even though they give better accuracy, when it comes to fraud, they are still not preferred. The reason being they're black boxes. And hence, now there is a lot of study which has been done. There are a lot of APIs to products which are available, which will explain, why a machine learning or an AI algorithm has given that decision. So that's one, so that's the future state that we are heading in 2020 onwards. The other is reinforcement learning, right? So again, right, so this is training of machine learning models to make sequence of decision, right? To give you an example, you all have heard about automated or self-driving cars, right? So you don't have any data for them, right? So your camera is the one, the self-mounted camera, which is collecting all the data on lane changing, braking, and these are being used to train a set of machine learning model to make not just one decision, but multiple decisions, right? So that's another thing that we will see more in 2020. The other is, as per, so Gartner is one of the organizations which does survey across companies, and as per them, by 2021, most pre-built analytical reports will be replaced by automated insights, right? So your platform itself will be able to generate insights instead of a user building those reports. And the last thing and the most interesting thing as students for you, right? The job landscape in 2022, right? So again, as per the vform.org, right? So one of the organizations who runs the survey, there will be about 133 million roles, right, across the world, right? And if you see the top 10 emerging, data analyst, data scientist, AI and machine learning specialist, big data specialist are figure out constantly in top 10, right? So a lot of scope, which means, the data, which is the new oil, is finding its way to turn decisions, which was earlier just left without even analyzing it. So now you'll have more and more industries coming up to speed with analytics, adopting the best practices in the data and turn their data to gold, which is nothing but informed decisions. So thank you very much. Again, it was really good to be here and give a small talk to all of you. Thank you.
Thank you, Deepankar.
Now I am requesting all our participants to ask their queries in the chat session, please. Now we are delighted to have with us Mr. Satrajit Kaur, Head of Advanced Analytics, Tata Insights and Quant, Tata Industries Limited. An alumnus of IIT Kharagpur, he has nearly 13 years of experience in the analytics industry. He spent nearly a decade with FICO in the credit risk analytics business as a conductor for banks and financial institutes across the globe. Currently, he works on building solutions for diverse problems in the manufacturing sector for companies within the Tata Group. I would like to request Mr. Satrajit Kaur to kindly deliver his presentation. Please, sir.
Hello, everybody. Hi. Let me know if. Hello. I hope I'm audible.
You're audible.
Yes,
Thank
sir.
you. Thanks a lot for giving me the opportunity. It's really a great opportunity to be able to talk to what I have been around 13, 14 years back. So really, I'm very pleased to be able to conduct a session with you. Introductions have already been given. And whilst I speak, there's a lot of heavy stuff that has been spoken about what we discussed was the basics of analytics, what analytics is about, supervised learning methods, unsupervised learning methods, and how these are being used in the industry, as well as reinforcement learning. So what we can understand is that the analytics space is quite huge, and there's a lot of scope. So for all you budding analysts out there who are in the computer science, physics, or mathematics department, it's a wonderful world of analytics that is, I think, is just shaping its arms and wings and trying to fly into, I don't know, whatever unknown grounds there are out there. Seems to be a very very interesting space, and obviously a lot of work that needs to be done in that space in the future. And that is what we would look forward from young budding talents like you all, right? Before I just, I understand that there is a mix of different experience of students who are gathered together, and a lot of things that we might be saying might either be going tangential or might be something that you already know, something that you have already studied. So since I'm not very aware of how that entire distribution, if I call that, is like, so I'll try to mix and match, right? But just before I start, a small, maybe a word of advice from somebody who has been there around around a decade and a half back. Thing is, when I was a student, I was in the maths and computing department at IIT Kharagpur, and at that time, I loved to do coding. Coding was something that really interested me, and mathematics not so much. I loved mathematics before getting into IIT, but after getting over there, there was so much of nitty-gritties and nuances and so much depth of analytics that I started not liking it so much. Whereas when I went into the analytics industry, I really used to repent that. I mean, why had I not paid more attention to my mathematical subjects? Trying to understand distributions and spaces better would have maybe given me a slight edge when I actually went into that analytics world. So although the thing that often plagues us is because we do not have a very good idea of the application of analytics, or application of statistics and mathematics whilst we are studying it. What happens is that we start either not liking it so much, being afraid or scared of mathematics, or maybe thinking that it's too much jargon, too much bits and figures and all that, and we try to shy away from that. So I think that, if you are able to, what might make the study more interesting is always trying to come up with applications. What are the real life applications that are being used for each of the mathematical modules or statistical modules that you study? And that might be, that I think in retrospect would be quite helpful, or would make the subject a bit more interesting. Actually, very interesting, computer science, physics, and mathematics combined. Anyways, without further ado, I'll start into my presentation. And before I go into time series forecasting, so what we were discussing was about prediction or analytics in general. So let me give you a couple of, even before we start, the way that I understand it, supervised learning is something where you are trying to predict something. Unsupervised learning, you are not trying to predict something, you are trying to gain insights. So supervised is if you already have done certain courses in mathematics of dependent variables versus independent variables, right? If you are already aware of that, so that might give you a hint as to what supervised learning is about. Supervised learning has dependent variables which are predicted using independent variables. As professor was earlier giving an example, like you're trying to predict the number of car sales or something similar using certain other independent variables. So that's supervised learning. Unsupervised learning, where you are not trying to predict, you're trying to cluster or trying to form groups to be able to understand how things might work out. Time series forecasting usually, and it does not contain the entire domain, but time series forecasting is usually predictive. It tries to forecast something that is going to happen in the future, and thus it is a supervised learning that happens in the space. Now, whilst we are talking about predictions, supervised, unsupervised, etc., what is the need of time series forecasting specifically? Why suddenly, of all the different discussions that we are having over here? Sure. So, why time series forecasting? What is so very different about it? Okay. So, say if you are predicting, say, car sales, you must start imagining the data surrounding that, right? So you have certain records corresponding to each of the car that sold maybe, and certain specific information, independent variables as we call it, surrounding those, like what is the maybe the region, what is the kind of person who bought it, I mean, what their age, gender, income, marital status, some descriptions maybe of the showroom, the time of the year, seasonality, seasonal factors surrounding that. So using all of this, you're trying to predict maybe the car sales of a certain region of a certain time or whatever that might be, right? Or you might be trying to predict something like, say, if I'm trying to give a credit card to a certain customer, whether he or she might default on that. So predictive. So all these are predictive problems, but what is different about time series forecasting? There is a chronological factor. Each record is associated with the previous record. I can, sorry. So each record is associated with the previous record. And that is what is, I mean, there is a chronological dependency. Usually when you are trying to have a predictive model, if you jumble your records, if I might say that way, if you jumble your records in any way whatsoever, there's no problem because each record is independent of the other record. Whereas in a time series, as you can understand, there is a chronology. If you're doing it at a monthly level, then there is January and February, March and April and so on. And April is dependent on March or February or January. It might be or it might not be. So there is a possibility that the dependency is there. Not so when you are looking into other different kinds of predictive models. Now, what are the different kinds of time series forecasting? As you can see on my slide that I have been projecting for a while now, this looks at certain air passengers over time. So one thing is that what we can see that from 1950s to 1962, for the duration of which this data is there, we can see that it is only increasing, right? So that is a trend of the data. Then what are the other things? You can see that there is a seasonal pattern. You can see that it increases by a certain pattern and peaks, and then it drops off, which means that the air passengers, there might be a certain seasonality, which means that air passengers are higher in certain times of the year and not so high in other times of the year. So these are certain factors that affect usually a time series modeling approach. And then using that, you can maybe, if I were to give you data till 1961 and asked you to do it for 1962, you might just, given you a red pen, then you might draw this the last part, which is the prediction. You might just sort of extrapolate the other parts or the historical data into something such which might give you a prediction, right? How accurate that be is other question. So what are the usual business cases where we see time series forecasting being used? One is like, say, a certain company or an organization needs to forecast sales for the next 3 months. Somebody needs to, so that they can accordingly adjust their business. Price forecasting, something that at Tata IQ we have been doing for a lot of companies who trade in commodities. So there are different Tata companies who buy steel, aluminium, copper, and other such metals. They have to, companies like the steel companies, they have to buy things like iron ore flux, metallurgical coal in huge quantities, in upwards of $2 billion USD. So if we are able to give them something like a price forecasting model, what is the price going to be, say, after 3 months or 6 months, then they can negotiate better. They will be able to plan better. They will be able to know, should I buy now or should I buy later? At what price should I negotiate? So these makes price forecasting models very powerful, but at the same time, the accuracy is very important, right? I actually, the prices go up after 3 months, but I had predicted the prices go down after 3 months. And looking at my model, the strategic decision that somebody had taken would be completely opposite. And then the model will just murder their business, something we absolutely do not want to happen. So the accuracy in a price forecasting, or for that matter, any sort of a forecasting model, definitely needs to be taken with a dash of salt. And it's very important. It can turn your strategy upside down. How do you look at that accuracy? Similarly, revenue forecasting. So basically, everything is about forecasting. Everything is about forecasting revenue, price, sales, whatever that be. Now, going into some of the nuances. So say, as you can see on the top left-hand chart, there is a particular time series which is like this. And then it has got three components, as I was speaking. There is a trend component. You can understand that if you generalize that particular chart, you get that particular trend over time without the nuances. It is something like fitting a simple equation into that line to get the trend. Then there is a seasonal component, as we saw in the air passengers data as well. How big is that seasonal component? We can see from the amplitude of its variance. In this case, as you can see, the total thing varies, goes to something around 300, whatever that chart be of. And then we have a seasonal component which only varies from around -10, -5 to around 15. So we can see around around 10% variation across season. So that is how you can understand whether the seasonal component is significant enough. And once you have taken out the trend and the seasonal component, you are left with a residual, which you try to model using different kinds of modeling techniques, which I will just talk to you about. Okay. One thing might be a good idea is that, as I said, a lot of these things might be already common to you, something that you already know, in which case you can go into a snooze mode maybe, or it might be something which is entirely new to you and very difficult to grasp. Basically, we all have just half an hour to share whatever we think is important, and that might be too small a time to be able to give a very comprehensive outlook on a certain subject, right? So that is the reason you might want to make small notes of this, and that maybe later on. Google right now is one of the best books or best educational systems that I believe we have at our free disposal. So we can make use of that and want to make notes of some of these and maybe go into Google and later read about some of these topics, which will make understanding a lot easier for you all of you. Okay. Anyways, getting back to what I was speaking about. So there is something called the non-stationarity. If you remember, I started off with this point, like the points, each data point is not independent of each other. All of them are associated by time. And that is what makes time series forecasting different from other predictive models. Now, that is what is also about the non-stationarity of data. If you remember, Deepankar, while he was giving his presentation previously, he showed that how the sales have evolved over time and how shaved heads have evolved over time. And both of them have a correlation. So if you think about it, if you look from 1950s to now, the prices of bread as well as real estate have all increased over time. Most of the things have all prices, if you look at them, have increased over time. So if you were to build a model, if you look at that correlation, are they all correct correlation? No, everything has increased over time. So you have to take that time component away. And that is basically basically the non-stationarity of time series data. You have to make them stationary by taking that trend component out of time. So that is the first step that needs to be done. There are different approaches like augmented Dickey-Fuller test, etc., which help you understand whether a particular time series is already stationary or not. But that is the first test that you have to do, because everything has increased over time. So if you just blindly go into building a model, you might be fooled by the time series. Okay, so this is something that we already discussed. So what else is there in time series? There is an autoregressive effect. What do I mean by that? So if it has been raining for the last 4 days continuously, I would say with a high amount of confidence that tomorrow it might rain as well. So I will have a high amount of confidence of that. So that is the autoregressive component of time series. If something has been happening for the last X number of days or weeks or months, there is a high probability it will repeat for the next Y number of days, months, or weeks, whatever. What is moving average? This is regarding something like volatility. So if there is a huge amount of volatility in the recent days, that amount of volatility will continue in the next X number of days. If things have been relatively stable over the last few days or months, then we expect things to be stable in the next few months. Obviously, from time to time, we are met with black swan events like the current situation, the current pandemic. We never thought that this is going to happen. Things might have been going quite flat from a certain, say, steel price point of view. Things were not very volatile, things were going quite stable, and suddenly the COVID happened and prices started dwindling down, started falling abruptly. Nobody had even thought about that. So those are called black swan events, and they affect you from time to time and throw all your models and all your speculations and forecasts down the drain. But still, you can try to do whatever you can. So again, repetition of something that has been talked, just has been discussed about. It's called causality. So first task, once you have looked into the stationarity and the trend and the other components that we just talked about, the next thing to look into is establishing causality. What does that mean? So say we are able to establish that if there is a 6-month lag between GDP and unemployment. So if the GDP falls, then the unemployment rises. Hope that does not happen. Ardently, I would not hope that that happens in the near future. But say supposedly a hypothetical case and something that you might be identified from the data. So we are able to establish causality between GDP and unemployment. So we are trying to forecast unemployment and we see that there is a lead causality of GDP towards unemployment. If GDP starts plummeting, we can see a similar sort of a opposite correlated trend in unemployment, but followed not immediately, maybe 6 months down the line. So that is what causality is about. In time series, it is very important to identify the lead causal variables. Say, suppose I can see that an inventory at a certain stockyard, at a certain region, if it starts falling down, then the prices of that particular commodity that is stored in that warehouse keeps growing up. Okay, so these are the kind of causalities that is very important to identify in a time series model. And just to mention again, you can take a note of that. I would, again, in the interest of time, I wouldn't want to go into the details. But Granger's causality test is usually used to establish causality, right? Okay. Requesting again all of you to please mute your mic if possible. Thank you. So, some background noise that is there. So request you to please go ahead and mute yourself. If in
All participants are requested to please turn off their mics. Thank you.
Okay. Now, quickly going, again, not going into any amount of detail, but you might want to make a note of some of these. So quickly mentioning some of the methods that are used currently, best practices used in the industry. So there is this most basic time series model, which is called an ARIMA model. This is a univariate model. What do I mean by univariate model? So you use only variable X, historical values of variable X to predict X. You're not using anything else. You can look into its seasonality of X, but only from X you are trying to predict X. No other variable is used. ARIMA is basically an acronym for autoregressive, integrated, moving average. What is autoregressive? We already talked about that in the last slide. What is integrated? It is nothing but the trend, that stationarity. How many times you have to take the difference. So usually to convert a non-stationary data into stationary data, you have to take certain number of differences to do that. Usually one difference suffices, usually from my experience. But yeah, the number of differences that you have to take, that is called the integrated part of ARIMA. And finally, MA is for moving average. The volatility that we talked about. So this is one of the most basic techniques that you would want, that you can use. The next one is called a VAR, or a vector autoregression technique. This is a slightly complicated technique, and it uses it's a multivariate technique that you are using other variables to predict a certain variable. or you use a combination of variables to predict or forecast their points in time in the future. This is very powerful. So what happens is that I'll just go into neural networks in a bit, but right now we usually machine learning is an all-encompassive subject. Statistical models, parametric models, all different kind of models that you can find out there, all ideally go into machine learning. But usually when we talk about machine learning, people think that we're talking about more advanced non-parametric methods like, say, boosting methods or bagging methods or neural networks or support vector machines, etc. Statistical models always are not certified as a machine learning model. So, however, the problem with those kinds of models, the more advanced ones, is that with small amounts of data set, they don't work so well. Okay, they need copious quantities of data to be able to train themselves. And that is the reason, these basic statistical models, they are found to work quite well with small number of data points. And in time series, although you would love to have data at a very granular level, maybe at a second level, to be able to do your stock price forecasting, etc. But usually when you're doing commodities price forecasting or a lot of these, you have monthly data, sometimes yearly data, like rain forecasting, etc., weather forecasting, you might have daily data. So the problem is that you do not, and the number of data points, say you have 10 years of data, daily data. How many data points? 3,650 or maybe 52, accounting for leap years. But whatever. The point is that those are not huge or enough data sets to be able to train a neural network sort of a model. And that is the reason you might want to fall on these more simpler models, which were quite 120 data points, which we usually have for monthly forecasts. So vector autoregression plus vector error correction models is a very good time series forecasting model as per our experience for predicting where you have data points which are not so huge in number. Okay. And now going into some of the machine learning methods. So LSTM, or long short-term memory, is one of the most often used method, which is used for time series forecasting or anything like that. It's not only time series forecasting, wherever you have sequential data. It can be for, say, creating, for natural language processing. If you have heard about that, natural language processing uses a lot of LSTM models because it has got sequential data. What is natural language processing? Where you are looking into unstructured data. You're trying to predict the gender of a certain in a certain text, or you're trying to create prose or poetry using machine learning techniques. That's also being done, and the quality of those, if you actually go ahead and see, you will not be able to differentiate that from being written by a well-known poet. At least I am not able to do that. So yes, wherever there is sequential data, long short-term memory is used. Now, you might not be very well aware, and this diagram over here might not help you a lot in understanding what that is. So I will quickly go into how you should, if you want to learn about long short-term memory, what is the what is the sequence that you should follow to be able to learn about that? So you should start reading about neural networks. What about neural networks? You will start with a single layered perceptron. So as you can see on the top left corner, we have a single layered perceptron. You have inputs and then you have an output. Now, what is the best thing about neural networks was the addition of hidden layers, and that is the reason it became deep learning. So deep learning is a neural network with hidden layers. So that brings us to the right of the screen, which is the multi-layer perceptron. So there's an input layer, then there can be one or more number of hidden layers consisting of any number of nodes, and then there is an output layer. So that's called a multi-layer perceptron. In the interest of time, sorry, I cannot go into the details of these, but if you have to follow an educational route into neural networks, this might be some of the things that you would want to check and make as like check boxes, milestones along that journey. Now, within multi-layer perceptron, within neural networks, there are very different kinds. We talked about image processing in one of the sessions, right? You usually use convolutional neural networks for image processing. I'll not go into that. But for time series forecasting, it started off with RNN, or recurrent neural networks. So what was special about recurrent neural networks was that each node also had a connection to itself. So if you go into the multi-layer perceptron, you will see that there are various number of nodes, and all of them are connected and interconnected in various ways, and they're directional, etc. Again, not going into details of that. But what the additional complexity that was added in recurrent neural networks was that each node had a connection to itself as well. So basically, to take care of sequence data, basically time t minus 1 had a relationship with time t. There is a connection between t minus 1 and t, and from t to t plus 1, and so on and so forth. So to be able to take care of sequence, recurrent neural networks were introduced. But the problem was, if something happened long back in time, recurrent neural networks was not so useful. Some event happened 12 months ago, recurrent neural network could not remember that. It couldn't build a model which could keep things which was long back in time. It could only associate things which happened in a short duration. It had a very short-term memory. Similarly, when it was applied for natural language processing, the same sort of a problem was prevalent. What was it? There is a long sentence, something that happened like 7, 8, 12 words back. Recurrent neural networks could not understand the nuances of such an occurrence. It was only able to associate something that happened immediately 2, 3 words prior to that. And thus came long short-term memory, which is a variant of neural networks, but it has got those certain gates, different kinds of gates. Again, not going into the details of that, but yeah, it has certain gates through which it trains the model to keep in its, it decides what should be forgotten and what should not be forgotten. So it will keep in its memory certain things which might have happened long back, but what the model has seen while training, that even things, certain occurrences long back should be retained because they might have an effect in the future. So it will retain only those certain bits of information for future usage. So that is how the long short-term memory was introduced. Again, this is definitely not sufficient to give you a holistic idea. This just introduces you to the subject. That is the idea. And for you, the idea is the next level would be for you to go back, Google, or get into any program, or maybe you might have already courses lined up in your department as well, which might give you much more broader ideas of that. So with this, I'll conclude whatever I have been talking about. I'm sorry, I think I have slightly overshot the duration, but yes, I would want to final some words of advice is that try to just make notes of this. Try to go ahead, Google and read upon them. And please pay heed to your mathematics, because that's very important if you are interested in going into an analytics role in your future. As Deepankar has mentioned, the role of analytics, the scope of analytics is only increasing in the future. It's not going to know any bounds, and it's a very interesting, very alluring role to be in. And it's got a lot of scope for the future, but then it's good to know your mathematics well to be able to understand your analytics well. Okay. With these words, I'll stop, and thank you so very much.
Thank you, Satrajit.
Thank you, sir, for such an enthralling presentation. Now we are delighted to have with us Mr. Yazdan, data scientist, group data and analytics cell, Aditya Birla Group. With 6 years of experience, he is working with the data and analytics cell of the group. He has previously worked with Tata Insights and Quant Division and M.U.C Business Solutions Private Limited. He has a bachelor's degree in chemical engineering from NIT Allahabad. Now I would like to request Mr. Yazdan Khan to kindly deliver his presentation. Please, sir.
Thank you, Archita. Am I audible and visible?
Yes, sir.
Yeah. So first of all, I want to thank all the organizers and the honorable principal for giving me an opportunity to be a part of this webinar. And more so, I would want to extend my notion of thanks to all the attendees who have taken their time out for this session on a Sunday morning today. So thank you all. With that, I'll get started. I'll try and share my screen. I think the previous speakers as well as the professor have set the ground well for what analytics is all about and what we do in our day-to-day jobs. Today, I'll be speaking about how does machine learning decide your discount. But before we even go into that, we'll be talking about something that lies at the heart of this process, and that is the process of optimization, right? So we'll today understand what is optimization, learn about some of our applications in our daily lives, the way that we see all around us and how it affects us. We'll quickly understand and read about some of the different types of optimizations that are available. We'll try and see how we formulate an optimization problem from a real life scenario given to us, and we'll try and interpret the solution. And finally, we'll see the case study on optimization, that how do we decide discounting in apparel industry, which we did for one of our clients. Okay. So first of all, when you hear the word optimization, I'm sure what comes into your head from basic English knowledge is finding the best of all worlds, right? So an optimization is something where you are trying to satisfy all the stakeholders and all the parties involved. So let me give you an example. Imagine if a child goes to a chocolate shop with his father, and if you make the mistake of ever asking the child how many chocolates he wants, I'm sure he will obviously say he wants the whole shop. But that is really not possible always, because of the fact that the father will always have limited amount of money in his wallet. So in terms of optimization framework, the demand of the child is the objective function, which we want to maximize, right? We want the child to have as many chocolates as possible. But there are limitations to that. There are constraints to that. And what is that constraint? It is the amount of money that the father has in his wallet, right? And an optimization solution would provide you an answer with exactly how many chocolates are possible for the father to be given to the child, right? So imagine this is a very simple optimization problem, but you can think it can get really complicated as well. Imagine if the father also had to go for grocery, then he would have to keep that money separate aside and then decide with whatever amount of money that is left, how much he can get for the child. So so optimization framework is basically defined in terms of these three components that we will discuss in detail, and we'll see it in a few of our examples later as well. The decision variables, the objective function, and the constraints or the limitations. Now, how does it affect our daily lives? Well, sometimes we don't even realize why we are actually doing optimizations, all the time. So whenever you go to a shop and you decide to buy something, right, you are doing all sorts of optimization in your head. Okay, so we often hear of a word, called cheap and best. What does cheap and best mean? These are two counteracting forces. Cheap is generally not associated with best, but when you say cheap and best, you are actually trying to balance out both and achieve an optimum. That's what you do when you go out shopping. Similarly, businesses make pricing decisions to maximize profits. So how do they price their goods, right? Whether a t-shirt can be sold at a $3.99 or a $4.99 or a $5.99. How do businesses decide that? What is that optimum price? That decision, we'll see that later in our case study as well, is a result of an optimization process. Similarly, consumers make a lot of savings decisions, like the different channels and instruments in which they need to save their money in order to maximize whatever utility they can get. That also is an optimization result. And I think most common and obvious of them all is Google Maps. So when we set out from our homes or our workplaces, we all use Google Maps, right? So whenever we open Google Maps, it shows us one route out of many alternative routes. That route is based on the least amount of time that it takes for us to reach from a starting point to our destination, right? So that is a result of optimization. So I'm just trying to make things relatable in terms of how these things are affecting our daily lives and not just academic in nature. Okay. Okay. We'll talk about the types of optimization that are there. Optimization typically can be classified on the basis of the type of problem and the type of variables that are involved. Based on the type of problem, they can be either constrained or unconstrained. And based on the type of the variable, they can be either dependent or independent. Okay, so what does these constrained and unconstrained mean actually? So when we say constrained problems, these are problems that have some restrictions, whereas unconstrained problems are problems where there are no restrictions, right? So an example of an unconstrained problem is run as fast as you can, right? So there's no limit to it. We are saying just run as fast as you can. In constrained problems, we have constraints like run as fast as you can, but ensure your heartbeat doesn't exceed 100 beats per minute, right? So that is an example of a constrained problem. Similarly, when we talk about the types, the classification of optimization based on the variables involved, independent variables of an optimization are all those variables that are in the hands of the controller or the formulator. So for example, if I'm solving a problem for an industry where I'm supposed to change temperature, right? And I know that if I change the temperature, my pressure will change independently, then along with it, along with the change in temperature, then I need to be mindful of that. So the change in temperature would be my independent variable, whereas the change in pressure would be my dependent variable, and we would need to take that into account while we are setting the optimization problem. Okay, so now let's move forward to what we have typically as classical optimization. Now, classical optimization is pretty simple. This is that set or that school of optimization that typically solves problems related to continuous and differentiable functions. So if you would remember your class 10th or class 8th maths class, you would remember you finding out the first differential and then equating it to 0 and then calculating the maxima and minima. So this is something like that, right? So based on the types and nature of equations that are involved in the classical optimization, they can be either linear programming, quadratic, or non-linear. So depending on the type of equations that are involved in classical optimizations. So classical optimization can typically solve a certain types of problems. You know, there is a domain in which it works, and that domain typically consists of single variable functions type of problems where you have a single variable function, or you can have functions which have more than one variables and there are no constraints, or you can also have a case where you have multiple variables in a functions and it has both the equality as well as the inequality constraints, or only the equality constraints, or just the inequality constraints, and all the different permutation and combinations of these conditions. Okay, but as we know, all the cases that you are going to get are not going to be solved by classical optimization problems. This is for problems that are relatively simpler, which, as I mentioned earlier, are continuous and differentiable functions, right? For the rest, we have something called more advanced optimization techniques. Now, while I will just browse through them, I don't expect you to really develop a deep understanding after I have mentioned this to you. But as Satrajit mentioned earlier, you can perhaps take notes and Google them, and I'm sure you will not be disappointed by what these techniques can achieve. Okay, so the first one is hill climbing. So think of a situation where there are a series of hills, some small and some short, some very high hills there, right? And your goal is to reach the top of the hill, okay, the top of the highest hill, and you have a blindfold on, right? And you are suppose on one of the smaller hilltops, or while you are ascending one of the smaller hills, how do you decide if you are moving in the correct direction or not? You see whether you are going up in the correct direction, analyze if that's where you want to go, and you go ahead. If you decide and if you see that I'm moving in a direction that's opposite to my goal, you correct that, and then you move into a direction which is towards achieving the your goal, which is the top of the highest mountain. So something of the similar nature happens in this optimization technique, where a global optimum is achieved. Okay, there are two variants of it: simple hill climbing and steepest ascent hill climbing. The next is simulated annealing. This technique is another advanced optimization technique where what happens is, you know, annealing, right? So annealing is a metallurgical term that is used when you heat something to a high temperature and then you bring it down to cool slowly. Okay, so when you heat something to a very high temperature, what happens is the molecules start vibrating randomly, and that random nature is emulated in this optimization technique. So it works on that similar principle of annealing. Because of that random motion of particles in annealing, and because we are using that same theory, that same process here as well, we are able to achieve the global optimum without getting caught in the local minimum. So remember, I told you about the hills, the small ones and the big ones. So imagine if you are on the top of a smaller hill. So what this technique will ensure is, it makes you realize that this is not your goal. Your goal is to reach the top of the highest hill and not just the top of any hill, right? So this is something that simulated annealing helps with. Then there is genetic algorithm. This is a very advanced algorithm. It is very useful where you have multiple objectives. So when I say multiple objectives, for example, if a company decides that I want to maximize my sales, right? But obviously I don't want to incur more cost and expenses. So it says I want both these things as my aim and not one. So for such situations, genetic algorithm is very, very useful. And it works. It's very interesting because it works on the principles of genetics, mutations, and crossovers. Similarly, there is ant colony optimization. This technique is an AI technique that very interestingly again works on the pheromone laying behavior of ants. Okay, so imagine I'm sure you all get your timetables and schedules, and someone from your administration or your dean's department would be doing that. But this is typically used to solve for those type of problems, scheduling and timetable and so on and so forth. So as I mentioned, take notes of some of these and Google them, and I'm sure you will be intrigued by what these can achieve. Okay. Moving on, I'll talk about a problem, a real life problem, because I just don't want to limit it to theory. I'll try and show how we formulate a problem, an optimization problem, and how do we interpret the solution. So imagine there is a company, an XYZ enterprise, that makes automotive parts, camshafts and gears. Now, when it makes camshafts, it achieves a profit of $25 per unit. When it manufactures gears, it achieves a profit of $18 per unit. The resources needed are steel, labor, and machine time. But remember, there are restrictions that the total amount of steel that you have is 5,000 pounds. The total amounts of labor time available to you is 1,500 hours, and the total time of machine that is available to you is 1,000 hours. Now, we know to manufacture one camshaft, you need 5 pounds of steel, 1 pound of labor, and 3 hours of machine time. For gears, you need 8 pounds of steel, 4 hours of labor, and 2 hours of machine time. Now, the key question is, how many camshafts and gear does the company make to maximize their profit? right? This is a situation that can happen in any industry, right? It's a real life situation. Now see, how do we approach this problem? So there was a lot of information mentioned in text form. We have just represented that here in the diagram on the left that you can see. So we can see that all the things that we mentioned there are mentioned here in the arrows and all the numbers that are mentioned here, right? So as I mentioned previously, there are three important components of any optimization problem: the decision variables, the objective function, and the constraints. So if you see, the decision variables are two, how many camshafts you make, and then how many gears you make. That is C and G, right? Now, what is the objective function? Objective function is that you need to maximize the profit. So if you make C camshafts, you make 25 C, because $25 per unit is the profit on camshafts, right? So, and $18 per unit is the profit on gears, right? So you actually get a total profit of 25C plus 18G. So this is your objective function that you want to maximize. Now, what are your constraints? Remember that we only have a limited amount of steel and labor hours and machine time that's available to us. So we write that those same constraints here, that your 5C plus 8G less than 5,000 means that the total steel consumption for making these camshafts and gears cannot be more than 5,000 pounds. And similarly for labor and hours. The last constraint is obviously intuitive, that both C and G have to be greater than 0, because it is the number of camshafts and gears that you are trying to make, right? They will always be greater than 0. So having said this, if you write these equations and set up this formulation and put it into any sort of a software or algorithm or any sort of a tool, you will get an output with the adequate amount of gears and camshafts that you need to make. Okay, so as we can see in the solution, it is a linear program. Why we are saying that it is a linear program? Because if we go back and see, it is the objective function says 25C plus 18G, both are linear functions. If this was 25C square plus 18G cube, then it would not have been a linear program. How do we know that the solution that we get out of the optimization is feasible or not? Well, it's very simple. We need to check that it satisfies all the constraints that we have put or not. So all its constraints, as we have seen previously, are these ones, right? The amount of steel, the labor hours, and machine time hours, right? If all of these are satisfied, we know that our optimization has achieved a solution that is acceptable. Okay, I hope this gives some sense of how a real life problem can actually be broken down and formulated as an optimization problem and a solution obtained. Okay, so with that understanding, now I'll go to the case study part, which is how do we apply optimization and how do we decide discounts in apparel industry. Okay, so this is something that we did for one of our clients, and we'll see how we did that. So before we go there, I just want to explain, you know, how does price vary? So because when we are talking about discounting, what we are essentially doing is we are changing the price, and whenever we are changing the price, we are doing it because something has changed, right? Something around it would have changed. So what are the factors that actually affect prices? So some of them are mentioned here. For example, supply and demand. So if there is a higher demand than supply, we know that gives the leverage to the firm to set the prices. But imagine if there is very low demand and there is a huge amount of supply, then obviously the prices will go down, right? That's simple economics principle. Similarly, the next thing is consumer perceptions. So pricing optimally becomes very important because of the fact that if you price something that's too low, it feels like the products are cheap and substandard, whereas if it's too high, it just drives away customers, right? So there are some examples of brands, that actually burn off their clothing if they're not selling, right? If some of their products are not selling, they'll rather burn it off than sell it off on discount, because they're very cautious about their brand image and they don't want to tarnish that. So consumer perception becomes very important when you are pricing. Competition is obviously something that is very important, because you are in the same market, so you need to be mindful of what the competitors are doing. Then government regulations, so that's a no-brainer actually, because you have to fall in line with the law of the land. And an example of that, a recent example of this could be GST. So when GST came in, the goods and services tax, which is revised the indirect tax structure in the entire economy, many of the companies, and apparel industry was no different, had to revise prices for some of their products. So that is something that needs to be taken care of. Then there are technological trends that can sometimes drive changes in prices. For example, see the advent of e-commerce. Now, if you go to any e-commerce website today, whether it's Myntra or Amazon or Jabong or any other, you would see huge discounts there. And if a lot of the businesses who are operating in multi-channel mode, so when I'm saying multi-channel, I mean they are in stores as well as available on the stores, on the online portals as well. They might need to achieve for price parity, or they need to be aware of what's happening in the online world as well. So that needs to be taken into consideration when you're deciding your prices. And costs and expenses are obviously the most important thing. If your costs go up, then you obviously you have to sustain, right? You have to ensure that your profits don't drop, and then obviously the option that you have is to change prices, right? So that's broadly the number of factors that affect discounting. Now we'll talk about how do we go about deciding the discounts in apparel industry. Okay, so whenever you go to any of those stores, right, you might go to a Peter England store or a Pantaloons store or any of those stores, you'll see some products on 10% discount, some others on 20%, some others on 30%. So do you ever wonder why this particular product is on 40% and why this particular product is on 30%, right? There must be some reason why it is. And how do you decide that? So we'll see how that decision actually takes place. So it takes place on the basis of some of these factors mentioned here. One, I think, which Deepankar also mentioned previously, is the elasticity of products, which is very important. So it is nothing but a measure of the responsiveness to price change. So if you change price by 1 unit, how much change in sales is achieved? Okay, and what is the intuition that you get from that? So the intuition that you get from that is that if your products are responding to price changes, you will give a higher discount to those products only, because there's no point of giving higher discount to products that are anyway not responding to price changes, right? So the next factor that's important is the frequency of sales. So frequency of sales is nothing but the unit sales achieved per unit time. For example, if you look at a metric like sales per week, that would give you some sense of how the product is performing, and based on that you would probably want to give higher discount to products that have lesser sales frequency, because you want to catalyze their sales. You want to make sure that products which are laggards and lying behind and are not able to sell as good as the others, you drive those products sales through discounts. The next factor that we look into is current inventory. So imagine if you have a higher stock of a certain product in your store, then you would obviously want to get rid of that stock, because you want space to put in newer stock, and also because all that stock that is put up in shelf is something that's staying there, and it is not helping you get all the cash, and and is eating into your working expenses as well. Okay, so the intuition based on the current inventory is that you give a higher discount to product that is present in a higher amount with you, right? So you try and clear that. The next factor that's important to look at is the aging of a product. So imagine if a new design comes in and it hit the store, let's say in 2018 January, and then after 2 years, if you still find that product lying in your store, you want to give a higher discount to that product and get rid of that product, because again, for the same reason, you want freshness in your stock. So these are the typical factors that you look into when you decide discounts, and when you are trying to formulate an optimization problem, right? And then finally, how do we go about formulating the problem and solution? So the objective function, as I mentioned, is one of the components of the most important component of the optimization framework. Was a function of your elasticity, your frequency of sales, your current inventory, and aging. So all these factors that we just saw in the last slide, right? Then obviously there are constraints, and constraints are at two levels here. So there is an overall constraint, that your budget for discounting has to be less than the 30% of sales value. Okay, so the business was very clear in the sense that if 100 rupee of sales happen, I don't want to give more than 30 rupees of discount. So that is the overall constraint. However, there are a few product level constraints as well. For example, there can be a minimum and maximum discount guardrails for few products as well. For example, t-shirts, there can be a range that t-shirts can only sell between the range of 20% to 40% discount, while jeans may be sold in a range of 10 to 30% of discount. So you understand there are two levels of constraints that are working here, one at an overall level and then one at a product level, right? So then what you do finally is you put all of these together. So you have the objective function, you have the constraint, and you have the product level minimum and maximum constraints as well, right? So you put all of them together into an optimization engine, and your final output, which would look something like this, that your t-shirt A should sell at this much percent of discount, your jeans A should sell at a certain discount, and then so on. So it will give out a sort of a table listing that which product should be sold at which discount, and which is why you see different products being sold at different levels of prices whenever you visit a store, right? So that's where I end my case study. So that's all from my end.
Thank you, Yazdan.
Yeah.
Thank you, sir, for enlightening us with such an interesting case study. Now I request Shonga Roy to conduct the Q&A session. Please.
Shonga Roy from Department of Computer Science. Well, I would like to begin the question answer session by asking questions on behalf of our participants to our distinguished panel of speakers. Well, the first question is for Mr. Deepankar Arora. So the participant asks how to enter the field of data analytics after completing masters in computer science. Please,
Okay.
sir.
Yeah, sure. So can you hear me?
Yes, sir. Yes, sir.
Okay, so I think computer science and data science, those fields have quite a a big overlap, right? But as Satrajit mentioned, right, you need to be good in mathematics, right? So these days there are a plethora of courses that you can do. You can do courses on Udemy. There are even 1 years of master's programs in business analytics, specially designed by all the premier institutes in India, IIM, there is also Great Lakes, there is ISB, all of those are offering these courses, right? So you can do that before you enter, if you're specifically looking for skills in the data science domain, right? You want to do more of machine learning, artificial intelligence and other stuff. So that would be the best way to go about it, right? But since, as I said, that you're a machine learning and you have a strong, like you already have a computer science background in masters especially, and if you have strong programming skills plus your mathematics is strong, you can also learn all these skills through multiple courses available on internet, right? It can be from Coursera, it can be from Udemy. I can't I won't say that which is good or bad, but then you can do that, and based on your intellect you can enter the field of data science. So I hope I answered the question.
Thank you, sir. Well, the next question is from Mr. Satrajit Kaur. What are the various tools used in data science, and what technologies should we learn, and in what order? Please, sir.
Thanks. What are the different tools? Usually, open source tools are used by a lot of us for developing the models. What are those open source tools? Predominantly Python and R. Now, originally, a few years back, SAS, you might have heard of it. So SAS was this particular language. Along with that, they had their own tool, which was used for developing these models. But then you would have to buy a SAS license. FICO, where Deepankar works and where I used to work previously, they have their own model building tool, as well as optimization tool. They have their own tools, but right now a lot of open source tools are used. And as I said, Python and R are the coding languages that are used in most of these tools that are out there. There are certain tools which are like H2O, certain licensed tools like H2O.ai, etc., where you do not have to do a lot of coding. A lot of that is quite generic and inbuilt for you, and much easier for people who are a bit coding averse. They more senior people might want to play around with data, build a model or two. For them, such tools are more easier. But if anyone wants to understand modeling from scratch and get into the nitty-gritty of it, I would recommend using either Python or R for developing any of these models. So those I think are the more commonly used tools. May not be tools, rather languages that are used in the different tools that are there. From an optimization point of view, there are certain packages within Python like Pyomo, etc., using again open source solvers like GLPK or CBC. I think CBC is also open source. So some of these solvers can be used again within Python to develop optimization solutions, etc.
Thank you so much, sir, for answering. Well, the next question is for Mr. Yazdan Khan. The participant asks, what is the differences between data science and machine learning and artificial intelligence? Please, sir.
Yeah, I think that's a $1 million question that's asked. So people need to understand that when you talk about data science, that's the larger framework under which all sorts of analytics would fall into, right? Whereas if you talk about machine learning, that's a specific subset of data science where you use technologies where you train models. And if you go even inside that subset of machine learning, there would be a subset within machine learning which would be about artificial intelligence, where you deal with all the modern day tools and technologies like neural networks and so on. That will IoT, neural network, all of these come into the framework of AI. So it is basically a hierarchical framework wherein AI falls inside of machine learning, and machine learning itself falls inside the larger framework of data science. I hope answered that question.
Thank you, sir, for answering. So, one more question is for you. What are the practical implementation of the advanced optimization techniques?
So I mentioned some of them I mentioned while I was speaking. So for example, there are a lot of route optimization problems or problems in logistics that happen. So one of the problems that I know of is, imagine, any plant, any workshop where a lot of raw materials come in and a lot of finished products go by, and they have a certain fleet of trucks, right? So how do they optimize these trucks? How do they schedule which truck leaves out when and through which route? All of these are not going to be solved by some simple optimization techniques. They require some of the advanced optimization methods. For anyone who is interested, I would suggest just do a simple Google search for a traveling salesman problem. You'll probably try and understand what sort of problems can be solved using optimization and advanced optimization techniques, to be more specific.
Thank you, sir, for answering. Well, the next question is for Mr. Deepankar Arora. We have heard about genetic algorithms and deep learning. What dictates when we use one or other? Please, sir.
Yeah, so so it really depends on the complexity, what you're trying to solve, and also in a simple nutshell, it also depends on what your business users are trying to look to to derive out of the outcome, right? So you can't use a really sophisticated technique when your business users can't really implement it, right? So that would be the choice that would drive whether you use any complex technique or a simple technique which yet delivers you the result, right? So an example, an artificial intelligence model might give you 90% accuracy in case of bank, right? When trying to give credit card, right? But now the problem is the model does not tell you about anything about any attributes that you can control for. So in simple sale, it cannot be used by the banks when they are processing the credit card application. Now, but a simple logistic regression might give you something which they can control for, and hence the credit card application is simpler and smoother, right? So it would really depend on the business case, and do the business just wants to use it, is that a black box, just something from the data, don't even look at it, or you really want to marry the decisions, right? What data is saying versus what you want to do in business. So it would really depend on your business use case. Hope I answered it.
Thank you so much, sir. Well, the next question is for Mr. Satrajit. What is the difference between supervised and unsupervised machine learning?
So supervised is where you have to predict something. You have a dependent variable which you are trying to predict using independent variables. Like what is is it going to rain tomorrow? What is the probability of a certain account going default? What are the number of sales that are going to happen in the next month? So all this where you are trying to predict something, you use supervised. I mean, basically the technique is that you try to fit an equation or something where you have a y variable which you are trying to predict using different x variables. So that is the premise of a supervised learning. In unsupervised learning, there is no such objective in mind, or rather there is an ulterior business objective in mind. But while you are doing the model training, there is no such target variable or performance variable or dependent variable. So clustering techniques are I would say, the most common fundamental unsupervised learning technique. So suppose you have a lot of customers, you want to understand what are the different kind of profiles You're not trying to predict anything. You do not have a target variable. You just understand. You are trying to say what are the what are the different kind of ages, gender, income groups, etc. that might different kind of customers fall into. I want to form different segments and clusters out of them. So that is when you use the unsupervised learning technique. So to remember that with a dependent variable, it's a supervised model where there is no dependent variable. It's an unsupervised problem. Thank you.
Thank you so much, sir. Well, another question is for you, Mr. Satrajit Kaur.
Sure.
More number of hidden nodes in one layered network is better for the neural network. Which optimizer is better for which case? How do we distinguish? Please,
Right.
sir.
Sure, thanks. So the thing is that usually there is no such thing as more number of hidden nodes would be better. Then one would start going towards the infinite, right? So for every problem, for every kind of data, the quantum of data that you have, there is an optimal number of hidden nodes. How do you get there? You do it through a grid search. It's not only the number of hidden nodes, but for each node, hidden layers. For each layer, what are the number of nodes? What is the kind of optimizer? What is the kind of activation function? There are a lot of these other things that you would have to choose through. And for that, you use grid search. What a grid search essentially does is that you can provide that for these are the different ranges of my learning rate. There is something called a learning rate. These are the different activation functions that you should use. These are the different optimizer that you should use. So it will run all those different permutations and give you what is the best result. Whilst doing that, you have to keep into mind your bias and variance trade-offs, etc. But yeah, it's not always necessary that if you keep on increasing your number of hidden layers, your results are going to get better and better. There's only an optimal number based on the data and the problem. For the next question, which is what is the best optimizer? Usually, I think for neural networks, you would have three different kinds that are available, like LB, FGS, and then SGD, which is a stochastic gradient descent, and ADAM. But by default, an ADAM optimizer is used, and I have seen that ADAM optimizer works quite well. So my recommendation would be to stick with ADAM, but you can always try out in a grid search where you give the options of all the three, and the model will train itself on all the three and recommend you the one which is best amongst the three. You can try that using grid search. Thank you.
Okay, thank you so much, sir. Well, the next question is from Mr. Deepankar Arora. The question is it preferred by you to do MCA along with some online course on data science or machine learning after being graduated in mathematics? Machine learning or data science, which course is preferable? Please, sir.
If you are a mathematics graduate, so you can directly do any course in analytics, business analytics, and join the industry. MCA, I won't recommend, but if you really want to have strong computer fundamentals, the other path can also be taken. But my personal preference would be, since you are already a mathematics graduate, you should opt for any courses in business analytics. Yeah, does that answer the question? Thank you.
Yes, sir. Thank you so much, sir. Okay, I think this is the last question. So, thank you to all our speakers for patiently answering all the questions. That concludes the Q&A session. Over to you, Archita.
Thank you, Shanga. Now I would like to request our convener, Dr. Akash Lam, to deliver the vote of thanks and the closing address. Please, sir.
Thank you, Archita. We've had a wonderful afternoon with such enlightening insights from our eminent speakers. But like all good things, this too shall have to come to an end. I would like to thank all our speakers, Professor Sripati Mukherjee, Mr. Deepankar Arora, Mr. Satrajit Kaur, and Mr. Yazdan Khan for enriching us through their expertise and fantastic presentations. I would like to thank our respected principal, Sir, Dr. Sukriti Ghosal, for encouraging us to host this event. I would like to thank my fellow colleagues, Mr. Joydeep Dey, Mr. Anirban Bhaumik, and Ms. Sonia Banerjee for helping to make this event a success. I would like to thank Dr. Shishir Kumar Gorai for his extensive support and guidance. I would also like to thank the students of the Department of Computer Science, without whom this event wouldn't have been possible. Thank you all. Finally, I would like to thank all our participants for joining us today. After this event, please visit the event website. The link is provided in the Google Meet chat. Once there, you can submit your feedback and then you can enter your email address to download your participation certificates. Thank you all once again. Enjoy the rest of the afternoon. Thank you.